Hello everyone. My pattern recognition project title is Face Recognition based on SVD and HMM. Biometrics, we can also call it biometric authentication, refers to the identification of a human by their characteristics or traits. It is regarded as an ideal basis for authentication because of the strong stability and individual difference. Face recognition is a friendly, efficient application using biometrics. The SVD, which refers to singular vector decomposition, has some theorems. SVD can be used for extracting features from face image because of the stability of singular value, proportion invariance of single value, and the rotation invariance of single value. In practice, we generally use the larger single values and ignore the small ones. As this picture shows, from left to right are reconstructed images respectively extracted 5, 10, 15, 20, 30 characteristics, and this is the original one. As the number of characteristics grows, the reconstructed images becomes clearer and closer to the original one. We should normalize the single values to overcome the impact of such factors as uneven illumination. Here is a simple structure of feature extraction. At first, we do the gray processing, turning the original image to the gray level values. After SVD, the real values are obtained. Then we use some kind of algorithm to do the quantization. Then three values in a row are combined to one, and we give this combination a label. At last, we got the observation sequence, which can be used in next. HMM, hidden Markov models, are used to describe a Markov process containing implicit unknowing parameters. We use HMM for training models of face image. Here we use a front face image as example. The hair, the forehead, the eyes, the nose, the mouth come in the order from top to bottom. So we get this picture. This face image is a vertical scan in order from top to bottom. So the modeling topology is arranged in the same order. Here is figure of training model of HMM. The ORL database is used in this project. It is made of 400 face images whose format is PGN. All the 400 face images are evenly distributed to 40 subjects according to different people. That is to say, each subject is equal to one person. And each of the 10 face images in one subject is slightly different from each other in expression, pose, shooting angle, with or without glasses. And here's an example of ORL database. Now let's turn to the MATLAB program. This is the face recognition program in this project. The face REC M file is based on SVD and HMM model. The GEN data is for generating a training database. This part is an expanding part, and this test SYSM file is for testing. To save time, we have already finished the training procedure. And now let's run this main menu. Here we press the recognize from image. There are several PGM images on the desktop, so we can randomly pick up each of them. First, we choose the number 1. The program shows this person is S1, so let's check. This is number 1, and this is the subject 1. We can see these two pictures show this exactly same person. We can do another try. This time we choose number 5. And it said this person is S28. Now let's check. They are exactly the same person too. Then we can do the calculating recognition face recognition rate. We press this bar. In this procedure, 5 face images are randomly selected from each subject. We train this to total 200 images to compare with another 200 images. Then we can get the final rate. This may take a moment. And look at what we got here. The recognition rate is 96.5%. Now let's go back to the slides. As this figure shows, with the number of training images per person grows, the percentage of recognition rate becomes closer to the 100%. But in practice, it is normally impossible to get 100% recognition rate. So the overlapping sample can show the image feature in a way of utilizing the group vectors and get the effects of reduced dimension. Identically, training models of face image is important for improving the recognition rate. The more training models of face images we record, the more reliable the recognition will be. just the same as the figure before shows. I really appreciate Professor Wu for his patient and diligent guidance, and thank you for watching.